All right, we're back for 11.3, and in 11.3 we're going to go back to solving, and this time we're going to be solving equations that have radicals in them. The method for doing this is actually pretty easy. You need to first isolate the radical. Oftentimes this step will be done for you. Or another way to think about that phrase, isolate the radical, is to make it a square root equal to a number. After we've done that, then we'll be able to square both sides or raise both sides to the second power. And once we've done that, we'll have some solving. Remember all of your two-step equation rules and all of your factoring rules. It's going to all come into play here. So let's look at number 1. The first step is always isolate the radical or make it a square root equal to a number. That's been done for us. So now we can square both sides. What it looks like is that you simply put parentheses on the outside, and you're going to take the entire left side and square it, and you're going to take the entire right-hand side and square it. Now we've already learned from all of our solve by using a square root. We're doing the opposite now. We have a square root and we're undoing it. That's why we're squaring. They undo one another. So a square root is undone by a squared, so we're left with just the base, which in this case is 2y, equals 4 squared, which is 16. And now we're on our solve step. Divide both sides by 2. So that we get an answer of y is equal to 8. The next one's pretty easy. Give it a try. Come back and check your work. I'm pretty confident that you did just fine. I am a little bit worried about problem number 3 because sometimes when you see fractions, you guys start to freak out. So let's work all the way through number 3 together. The first thing we'll notice that the isolate step was done for you. So now we need to go ahead and square both sides. So when we do that, when you start working on your own, you're probably going to just do this. Take the left side and square it. Take the right side and square it. On the left, we end up with x over 2, right? Just the base, is equal to 1/2 squared. Remember that when we do 1/2 squared, it's just taking 1/2 times 1/2. So we end up with 1 over 4. Now we're up to our solving steps. And on our solving steps, to get x all by itself, instead of being divided, it needs to be multiplied. So we'll multiply by 2. So that x is equal to 2/4. And we can never leave that as an answer. We have to simplify all fractions. So we get x equal to 1/2. Now when you go down to the next row, that's when we start getting into the steps where we have to do that first piece, where you have to isolate the radical. When we isolate a radical, remember that we think of it, if it's simplified radical, which they are going to be because they have x's in them, then we can treat it like a variable. So if I had 2w minus 8, like in number 4, if it said 2w instead of that radical, it seems pretty obvious that you would divide by 2. So that's all you're going to need to do here. Isolate step is just make that radical equal to a number. So we now have the square root of x is equal to 4. Once you have that isolated, then your next step is to go ahead and square both sides. So we take the left side of the equation and we square it. We take the right side of the equation and we square it. We end up with the base is equal to 16. All right, give number 5, number 6, give those two both a try. Then we'll come back and talk about one more rule. All right, hopefully you're feeling very confident in those two problems. And we need to talk about number 7. Number 7 is a trick problem. The reason it's a trick problem is because it's really asking you, what number times itself, right? That's what a square root asks. What number times itself gives an answer of -4? What number times itself gives an answer of -4? It doesn't happen. There isn't a number times itself that would give you a negative, right? The only way to get a negative with multiplication is if I take a positive times a negative. So the moment you have a square root equal to a negative, you can write no real solutions. No real solutions. Now the problem becomes that you have to be careful that you always take a think step after you isolate. So when we look at that next problem, number 8, your first step is always isolate the radical or make it a square root equal to a number. So we're going to subtract 5 from both sides. And once we do that, we end up with the square root of x minus 1 is equal to -2. Is this okay? No, it's not. So that we would have no real solutions. Or if you use the empty set, that's fine as well. So a square root cannot be equal to a negative number. You have to do the isolate step first, because in number 9, if you don't do the isolate step, right, divide both sides by -2, we end up with the square root of 3x is equal to a negative over a negative gives me a positive 5. And now I can keep going. I can square 5 because there is a number times itself that would give us 5, or 3 times a number that would give us 5. So we end up with the base is equal to the number squared. And now we go into our solving work, divide both sides by 3, and you just simply end up with a fraction. Divide by 3. X is equal to 25 thirds. Many times we'll end up with problems that have a square root on both sides. Just be cautious when you do those. We might also end up with a problem like number 12, where we're going to have to FOIL. That's going to have to be for another video, and we'll probably talk about it in class on Monday.